All right. Hey, everyone. I want to preface this by saying that not all of the lectures this semester will be this kind of PowerPoint long description kind of deal. Make that full screen. It's just mostly the first week. There's a lot of non-technical stuff to go over. I think like halfway through the semester, when we do the design lecture, it'll be more lecture based. But for the most part, it'll be coding exercises and more fun stuff. So thanks for making it through these first couple of lectures. I know it's a lot, but today I want to talk about the history of the web and how we got to where we are and how we can open Chrome and Firefox and get to view the websites that we want. So we're going to start in 1945 with Vannevar Bush. He was the director of the Office of Scientific Research and Development, which was an agency of the United States federal government created to coordinate scientific research for military purpose during World War II. If you took CIS 100, you may have heard his name before, learned about some of the concepts that he came up with, like MEMEX or the differential analyzer. But in 1945, he wrote this article in the Atlantic Monthly called As We May Think, and a quote from that article is: "Consider a future device in which an individual stores all his books, records, communications, and which is mechanized so that it may be consulted with exceeding speed and flexibility. It is an enlarged, intimate supplement to my memory." So if you think about that quote, what does that sound like? You might think about how we access the web today, and you can get all your books from the Kindle store, or you can listen to your music and you can text. And so this concept that he came up with in 1945 kind of is the precursor to how the web works today. So even though this was a long time ago, what he was thinking about conceptually at the time is what we have nowadays, and it influenced a lot of the people that worked on similar technology after him. In 1964, we have Ted Nelson, and he is credited with coining the term hypertext as well as hypermedia in a paper that he wrote for the ACM, which is a computing machinery organization in the United States. And what he means by hypertext is text that displays on the screen with references or hyperlinks to other text that the reader can immediately access. So up until this point, you might have, like a document that lives somewhere, but it doesn't have any links to anywhere else. So if I switch over to, here's Dr. Fee's website, I'm on his homepage. Say I want to make it, or say I want to go to somewhere else on his website, I can click a hyperlink. These are hyperlinks. This is a hyperlink. See this changed, and now I'm looking at research.html. So this idea of being able to connect to different pages on the internet, that's kind of what he's describing when he says hypertext. And hypermedia is just an application where you can use hypertext. So the World Wide Web would be an example of a hypermedia application. So he's talking about what we call non-sequential text. So if you think about you're watching a movie, you start at the beginning, you watch the movie the whole way through, and then it ends and you're done. This is a different kind of media application than the internet or the web. So you might get on and you might start at one website and you go to a different website, or you think of something else and you open a new tab, and there's no starting at the beginning and going to the end. It's kind of a non-sequential flow. So he's credited with these two terms. He also starts this project Xanadu, which never really takes off because he wanted to make money off of it. Um, in 1969, we get the ARPANET, which is considered to be a predecessor to the internet. It was developed by ARPA, which is the Advanced Research Projects Agency, which is originally founded, which was originally part of the U.S. Department of Defense. In 1981, this expanded from just government use to include the scientific community. And then in 1991, they came up with a partnership with telecommunications industry that allowed for the development of a commercial version of the ARPANET that anyone could use, and this is what we now know as the internet. Here's a map of, in 1974, all of the nodes, I guess you could call them, on the ARPANET. So if you think about how different this is from the internet today, I probably have this many connections like in my house. In 1971, email was added to ARPANET. In 1980, Tim Berners-Lee creates Enquire, a hypertext database system at CERN. If you remember, CERN is a European research organization. They're also known for the Large Hadron Collider, which is the largest and most powerful particle accelerator in the world. So there's a lot of top-notch research going on there. And this guy, Tim Berners-Lee, created Enquire, which had these pages, not really like what we would think about as a web page today, but they had cards that included links to other related cards. So it was moving towards this idea of hyperlinks and being able to connect disparate pieces of information on the web or on the internet. One note about Tim Berners-Lee, it sometimes feels like the internet has been around forever since it has been around longer than we've been alive. But Tim Berners-Lee, for example, who's credited with coming up with the idea of the web, is like still active on Twitter, working on other projects. I think he's working on a security startup at the moment. So like the people who came up with all these things, they're still alive. They're still contributing. In 1987, Bill Atkinson at Apple releases HyperCard, which is a hypermedia application that lets you link through cards. 1989, we have Berners-Lee again. He writes this proposal that is meant to address information retention at CERN. So, research organization has a ton of papers, and he wants a way to connect all of this hypertext together, and he comes up with this idea, and it is what we know to be the World Wide Web today. In 1990, he writes HTTPD, which is a server daemon. A server daemon is like a background process. It doesn't really require user interactivity, but it's important because it's the first ever server software created. And I'll talk a little bit more about servers in the next section as well. And he also creates the first ever web browser called World Wide Web. And this is a picture of it here on the right. In 1991, we get the Universal Line Mode browser. This is the first browser that can run on multiple platforms. So the original one only worked on the operating system that Tim Berners-Lee was using on, or was running on his computer, which was the next computer. And it had no interface. It was completely done through the command line. And there's actually it's been recreated at this URL. I can show you what it may have looked like at the time. So World Wide Web, hypermedia, information retrieval. I actually have no idea how to use it, but I can type help. Let's see what that does. Oh. So as you can see, I have no idea what I'm doing, but it gives you a good idea of what the first browsers may have looked like. In 1991, we have the first ever website is launched. There were no screen captures saved of it, so we don't actually know what it looks like. But this is one from 1992, so it's very early. The content was explaining what the web was. You can actually still go look at the first website at this link as well. But how this looks here, kind of like a Word doc, this is still how basic websites look today when you don't add any of the second language we're going to learn in the class, CSS. So there's no styling, there's no saying what the background color should be or the text colors. So this is what just basic HTML looks like. In 1991, we have the first web server in the United States. So it starts in Stanford. At this point, a lot of people wrote their own browsers, which is kind of interesting if you think about you're making a website and you made your own version of Chrome or Firefox. So there wasn't a lot of consistency between browsers there. Here's a screenshot of the computer that Tim Berners-Lee was using at CERN. So it's a Next computer. In 1993, we get Mosaic, which is the first browser that allowed images to be displayed, and this was a big move towards more modern browsers. NCSA is the National Center of Supercomputing Applications, so another big computing group. Here's a picture of Mosaic Point 1. So this was the browser at the time. Not very pretty, but has an image. So benchmark by 1993, web activity is still only making up 1% of total internet traffic. So remember, the World Wide Web is not the same as the internet. In 1994, we get the first real release of HTML. HTML, again, first language we'll be tackling in this class. So a lot of people are starting to use the web more so now, so the traffic's picking up a lot. And this version, HTML 2.0, is used for a while until this next version, 3.2, a while later. Spyglass licenses Mosaic from NCSA and builds its own codebase. So basically, it took this browser and rewrote it so it could be used commercially. So they packaged it, sold it to other companies to make their own browser. In 1994, we hit 2,500 websites. This is also the year that Yahoo was founded. In 1994, Netscape is released. Um, it includes JavaScript, which is one of the important behavior web languages that is not covered in this class, but is taught in the major. So that's a pretty big deal. In 95, Microsoft releases Internet Explorer. So each browser had kind of decided to make their own proprietary tags, like elements that made text blink or move across the screen, but they only really worked on their browser. So this wasn't inherently bad to have all these new tags, but they kind of went against the spirit of HTML, which is that it's supposed to work on multiple platforms. It started as a way for scientists to share their information really easily. So not all users had access to every single browser that people were making. So if you designed a website to only work on one browser and somebody didn't have that browser, it made for some really ugly websites for a few people. So it kind of led to a bunch of what we call best viewed on messages, where you would go to a site and you might see a banner that says best viewed on this. And there's actually still some carryover from this today. So if you go to a site on your phone and it says you should only be viewing this on desktop or best viewed on desktop, that's kind of an annoying thing, but it was very common back at this time. So how did we get here? The web isn't rolled by any one organization. There are a few, such as the W3C, Internet Engineering Task Force, and the Web Accessibility Initiative that lead efforts on updates to browsers, but there's not really anyone that's saying exactly how browsers have to work. So um, all of these updates, everyone making their individual browsers led to the great browser wars of the late 90s. So in 96, Netscape had an 80% market share with their browser. In 97, Netscape we have at 78, and we have a new browser called Internet Explorer made from Microsoft. And Microsoft integrated Internet Explorer into their operating system. Also, in 1997, Windows was running on over 90% of all PCs. So why might this be a problem for Netscape if Windows is by default including their web browser on all of their Windows? As you might imagine, it was not great for Netscape because people, when they would get Windows, Internet Explorer was automatically on there, or um, the technical support people who were managing Windows computers didn't want to deal with two browsers, so they just left the default Internet Explorer on there. And this led to a huge antitrust case that was very well publicized in 1998, United States versus Microsoft, where Microsoft was accused of having an antitrust situation. And as you might expect, Internet Explorer soon takes over Netscape in the middle of the antitrust case. Their market share plummets, and Internet Explorer is becoming the main browser. In 1998, we get Google. So Google achieves dominance rather quickly. There was a giant influx of information being put into the web at this time, and the founders of Google realized that they could tame this chaos a little by introducing page ranking by popularity when you search. And so they become very important in indexing the web and allowing people to find the popular information that people are looking for. In 1999, we finally get a new version of HTML released, HTML4. And this is used until the mid 2000s. In 2000, we get XHTML, which is introduced as a new standard for web development, and it represents a shift in how the languages are constructed. You don't really need to know this, but SGML is standard generalized markup language, and XML is extensible markup language, and HTML is a version of a markup language. But XHTML is a lot more strict. Also, in this year, we get CSS, which means you can now style your websites. In 2001, we get Wikipedia. So Wikipedia is about 20 years old now, and there's an explosion of collaborative content and sometimes thought of as a precursor to the social media movement, since there was a lot of information sharing and discussions. 2002, Internet Explorer has a 92 market share and is dominating the web. And so a lot of web designers and developers just stop working on things that match other browsers and just make it for Internet Explorer since so many people are using it. In 2002, the W3C, which is the World Wide Web Consortium, which is an international committee that develops web standards, I mentioned it earlier, announces that we're no longer going to be working on HTML. XHTML is going to be the new standard for website development, and that no one should be doing anything else with HTML. There were many people who weren't happy with this because a lot of websites were already built using HTML. So if people switched to XHTML, a lot of the web was going to be unreadable. It would break. It wouldn't work with the new version. So people were pretty upset about this. So if you imagine, you know, in 2021, actually this feels like a 2020 thing. Imagine in 2020 someone was like, okay, we're changing the technology for how the web works, which means overnight YouTube, Facebook, Instagram, none of them would work on the web anymore, or any website that we're familiar with. So it was a pretty big deal. So there's a split between people that want to continue working and improving the current HTML and people who think that we should switch to the stricter version, XHTML. So while this is happening, we get Web 2.0. A lot of people consider this a misnomer because it implies that there was some major change in how the web worked or the software behind it, but there wasn't actually any kind of change like that. It just over time, naturally, people improved and added content, and it just really changed how the web looked, even though the underlying technology, for the most part, was the same. So back to our web drama, there's a big divide between the people that wanted HTML versus XHTML. So you had these two organizations that were basically divided on how they wanted to move forward. 2005, we have YouTube. 2006, Tim Berners-Lee says basically the switch to XML and XHTML just didn't work. So the W3 organization starts up with HTML improvements again. And this eventually leads to HTML5, which is what we use today and what you're going to learn in this class. So officially, XHTML 2.0 is done. In 2010, we get broad support for HTML5. So you can think about HTML5 as a cooperation where it's agreed on that new features should be based on HTML, CSS, and JavaScript. The code should be device agnostic, which means it'll work on your phones, your iPads, laptops, screen readers, with the goal being that everyone gets access to the information. 2012, there's pretty broad, reliable implementation of HTML5 in the web browsers that everyone's using. In 2007, the iPhone was released, and over time, people began using their phones more and more for browsing the web. So in 2013-ish, we start to see widespread mobile usage. And so a lot more people are using HTML5 for development from older versions just because they have features that work better on mobile apps, like making the screen responsive and stuff like that. In 2014, even though people have been using it for a number of years, the specification for HTML5 is officially released. And this includes a bunch of new tags that we'll also be learning. Here's a graph. This is from 2020, but it shows the distribution of what people are using right now. So you can see that Chrome, as of 2019, I doubt it has changed that much since then, but they had a 68% market share. And this next section, you don't have to worry about learning any of it. It's just it's just an explanation of how new features in the language actually make it into the browser or into the specification. So someone will come up with a working draft for a new feature, and the standard is published. It gets feedback. It's reviewed by the web community. People make changes, and then it comes back. And then you get into the candidate recommendations step, where you have a version that is a lot more mature. It's been reviewed, and then the goal is to get feedback from the community on how to actually implement it. Next, it becomes a proposed recommendation. So the users of standards provide input, and then it's submitted to this committee at W3C that actually reviews it more. Eventually, the W3C will recommend it, which means that it's been reviewed extensively at multiple steps by many people, and it's ready for deployment. And at that point, the browsers, Chrome, Firefox, whoever, they can go out and they'll actually implement the new changes, and that's how they make it into our browsers. So as soon as a browser supports it, developers can start writing code using the new features. So this is a continuous process, so we've had a lot of improvements to HTML5, and I'm sure we'll have many to come. So I hope that was kind of interesting for some of you. I know it's a lot of information, but it's good to know about how the web came to be and where it's going. All right, see ya.